Hi friends, welcome to my channel. So today we are going to explore Nucleo-64 from ST. So we'll start with the hardware component, whatever are there in the board. Then we'll write a small program to start with. So this is the board, whatever we have from ST Microelectronics. Let us open. Okay, so there is a small instruction sheet and detail about the board here, and we have the board. Open it carefully not to bend any of these pins. So here is the board. Let us go through the instruction sheet. So as the name Nucleo-64, it has a controller with 64 pins. So the controller is here STM32 L476RG. This is having ARM Cortex M4 core and runs at 80 MHz. It has 1 MB of flash memory and 128 KB of flash RAM. So you can see here the features are listed. This is the pin mapping, which pin is what. On the reverse, we have some steps to getting started with. We'll go through this while we'll write the program. This is the development system requirement, then development tool shells. So as you can see, it supports Scale, IR, GCC based ID, and Embed Online. So any of these we can choose. Okay, so here on the development board, you will see there are two parts. This is one part, this is another part. So if we divide it, so on the left side, this is being one debugger. This is ST-Link debugger and programmer, which is attached to the controller part. So here is our controller plus all the peripherals, whatever are there, like GPIO, LED, push button. So this is on this part, and this part is only the debugger plus the programmer. So we don't have to have another debugger or programmer to upload the program, download the program here, and we can just need this board to start with. So just we need to connect this board or debugger to the PC, the development PC, and we can start with the complete thing is here. So we don't have to have any programmer or debugger in addition to this board. Okay, so this is the USB cable where we will be connecting this board to the computer. This will get power, this board will get power from this USB port as well. This LED here on board LED is there, so this will act as the indication for this program or debugger, any transmit and receive from the PC or from the host PC. On this board we have a couple of pin out here, so these are Arduino compatible pins, so you will see, and the pin details, which is which port or what functionalities are there, we can get it from the schematic, either from the schematic or here as a quick reference. And on the board you will see here we have two push buttons. One is the reset, this is the reset button, and this is the user button. So this user button we can use in our program to program any input, like some general purpose input we are programming, so we can use this button, and this is required for resetting the CPU. Here you will see one LED is there, that is LD2, and this is connected to one of the GPIO here, and where it is connected we can see, or we can go while we will be programming it. Okay, so I think that's good enough for now, and we'll start with the program. Okay. So here you can see from the STM website, if you were going through all the product and evaluation tool, go to this STM32 Nucleo board section. So if you'll see, there are 76 board over here, and this Nucleo-64. So before we start programming, we should know what are the features this board has and what is the controller we are using, so that we can understand what application and what GPIOs or any resource of the controller we can use. Okay, so again, Nucleo-64 has if you'll see, it will give a list of different boards available. We can make a quick search, and if you'll see, our board is Nucleo L476RG. So we can make a quick search here, L476RG. Okay, so this is here. Then go to this. Open product. Here it is. So yeah, again, all the features will be there. We can read more, Arduino compatible, and yeah. So if you'll see, here also you will get some of the example and how to start with. Okay, so the important thing here is to look for the controller, whatever is there on this board, and what are the features on this board which we'll be exploring. Okay, anyways, this is the board detail, and if we go to the data sheet here, STM32L476RG, this is ultra low power with FPU ARM Cortex M4, I told already, and it has being 1 MB of flash memory, LCD, USB, OTG. Okay, so these are the features. This is the block diagram of the controller, what are the peripherals we have, and has a few more details, and we can go ahead and download the datasheet here. So so datasheet is a good reference document. So anything we are starting with, we should have a look on the datasheet, and here we'll get details regarding what are the GPIOs, what is the clock frequency, all the registers to access all the peripherals, and so on. So yeah, I will not spend much time here unless it is required, but keep it handy before you start the programming. Okay, so to start programming, we need the tool called STM32 Cube, which can be downloaded from ST Micro Electronics. So this tool is already downloaded in my PC and it is installed, so we won't be spending time on downloading that. So if you'll see here, this is the STM32 Cube IDE, and when we'll open STM32 Cube IDE after installation, you will have this kind of page here, and once you have downloaded, you need to log in to your ST Microcontroller account. Don't worry, that is free. You can create your account for free. And once you downloaded and installed the IDE, you need to go to File, New. Then here you have to choose STM32 project. we have several other options as well, but let us start with STM32 project, and in our subsequent videos and in future we'll explore other options as well. Okay, so first starting we'll choose STM32 project. So if you'll see initializing STM32 target selector, so whatever targets are there, whether it is MCU or any development board, it will initialize that. At this point we need internet connectivity, so please check you have internet connectivity in your development PC. Okay, so if you'll see here, there are a lot of tabs, a lot of options, so don't worry about that. Gradually we'll learn all of these. So if we are using a custom board, so we need MCU and MPU selector, but in our case it is a board from ST, so that is not custom made, that is a board from ST. So you can directly go ahead with the board selector. Okay, so here is the board selector, commercial part number, as we saw, this is Nucleo L476. So type Nucleo L476, sorry, Nucleo. Okay, so this came Nucleo L476RG, that is exactly what we were looking for. Select this, and on the right side, on the right side bottom, we got this board Nucleo L476RG. So just choose this. So if we'll choose here, so as we saw on the website, this will give a brief and the feature of this board. We can even download the dataset, so we don't have to go into the website. Even we can see all the details, and we can download the dataset from here. We can go to the site where we can purchase this as well. So yeah. So only the ID is required. We don't have to go to the website and find out all the details there separately. Okay, so after selecting this board, click next here, and it will ask the project name. Let us give one Blinky. Okay, so and you can browse and select another folder where you can save your project. Otherwise use the default location. So the ID will choose the workspace where it will be saved, the project will be saved. The target language, let us go with C. Now we can have C++ as well. Target binary type, this is not library, this is executable. Means what a program will be writing is intended to run on the microcontroller, so this is executable, not a static library. Targeted project type, empty or STM32 cube. So choose STM32 cube so that we'll have some of the initialization done by the IDE that we'll see now. Empty will create an empty project where we have to add everything manually. So let us choose STM32 cube. We can click finish here, but let us see what is there on next. So in the next page, if you'll see, we have the package version. So this is STM32 cube. We will be using STM32 cube, and the version is all the available installed version will be shown here. So choose the latest or whatever you like. In some of the versions there are some bugs in the library, so based on your requirement, if there is some bug, we can go down to any version, or we can simply use the updated version. So if we don't have to choose the version, so from the previous manual only we can click finish here. So if you finish, it will ask initialize all peripherals with their default mode. Okay, so as we are using the development board, it will initialize with the default mode, like the LED is connected to some port and the push button is connected to some port on pin. So it will initialize with that mode. So let us click yes. If we have a custom board, then this option is not required, and we have to set everything manually. So let us initialize with default mode. Click yes. So it will load the IOC. This is as I told, we are using the cube option, STM32 cube. So this is generating the IOC file. IOC stands for IO configuration. So what the STM32 cube does is, graphically we can configure some of the ports, pins and other resources. So we'll have this once it is initialized. So yeah, so as you can see here, this is having the controller image with all the pins listed over here. Okay, so as I was telling, this is one IOC file created, this blinky.ioc, and this is the default configuration loaded. We said yes to loading the default configuration. So if you'll see, all some of the pins are already configured. Okay, so here, as I was telling, that IOC file stand for IO configuration. So all the IO as well as some of the resource we can configure from this page. We don't have to write manually the code. Okay, so we can just simply see, this is port A pin 5, PA5, and this is connected to LD2. So as we are seeing on the board, LD2 is connected here with the LED. Okay, so LD2 is the green LED connected to GPIO PA5. So this is already configured as GPIO output here, and if we want to modify this to some other peripherals, like let us say ADC input, so we can just click here. Okay, and it will the image will render again, and it will again reconfigure as per our configuration. So if you'll see other pins, PA2, this is configured as UART TX pin. So if you don't want, we can just simply click it back, and it will reassign with some other feature or whatever. If it is not assigned, it will simply clear that. So this is UART, it was UART RF here. So if we have removed that, then we go away, or we can assign with something else as well. So it was assigned to USART TX, but we assigned to, let us say, assign back. Okay, okay, the option is not coming. Reset state. Okay, orbit, or press Ctrl Z, so it will undo your selection. Okay, anyways, we'll keep it as whatever it was. Default will not disturb because it is loaded with the default configuration, whatever is there with the board. Okay, once this is done, so let us go with the other configuration. We have this is pin out and configuration, then clock configuration. So we can choose the clock, and we will see a schematic version of the clock, how it is going to use the peripheral. So the input frequency is 32.78. This is connected here, and how it is going through all these stages, and finally assigned to all the peripherals or the CPU. So this will go later Again, we'll revisit this again in subsequent videos. Then project manager. So here name of the project, then heap size, stack size. This will go later again. And tools. Some of the tools we have, we can calculate the power consumption for the program or the configuration whatever we have as of now. So we can calculate how much power it will take for our configuration. Okay, so as this is our first video, we will not go through all this clock configuration and the tools in detail now. In subsequent videos we'll go. So along with the pinout here, we can configure other system as well, like TMA, NVIC system. Then in analog we can configure the ADC, DAC, op-amp, timer. So whatever timers are there we can configure. Then connectivity, in connectivity UART, I2C, SPI, everything we have. Security computing. So these features will go one by one in later videos. Okay. Okay, if all the configuration is done, for now we have not changed anything. We saw that the LED. So our motive of this video is to program and blink this LED. We'll toggle this LED. We'll make it on and off. Okay, so that is the goal of today's video here. So we will not change anything here now. And if everything is done, just Control and S. It will save the configuration. It will ask, do you want to generate code? Click yes. So this will change the perspective. So do you want to open the perspective now? So now we are seeing the IOC file. So when we'll save and generate the code, it is asking to change the perspective to the code view. So click yes. So now the code will be shown here. It will update the code from the configuration whatever we did, and it will open the .c file. So if you'll see, this is the main.c, and as we are talking, this code will be initialized with whatever configuration we did. So if you'll see, HL init, all these code blocks will be added automatically. So GPIO init, we did the GPIO configuration, and we did the UART configuration also. So if you'll see system clock configuration, so this is loaded by default. Then this is the UART configuration. So UART is initialized with this baud rate. If you want to change the baud rate, we can change from here as well. And we will be not using the UART here, by the way. And if you'll see the GPIO init. So as I was telling, the GPIO pin, so it is configured as LD2 pin, means this is the pin where the LED is connected. So here you may get confused that LD2 pin, there is nothing like LD2 pin, right? Whatever we have is port A, pin 1, 2, 3, 4, 5, like that. So what is LD2 pin? So if you go here, click here, and you go here, if you see here, LD2 pin is GPIO pin 5, okay, and LD2 port, LD2 GPIO port is GPIO A. So this is again defined. It is defined in the main.h. So there is nothing like LD2 pin or LD2 GPIO. Okay, this is defined here in this main.h file. So when we choose the board as Nucleo-64, all these configuration came automatically. So don't worry, we can just write directly the pin number here, instead of LD2 pin, we can write GPIO underscore pin 5 underscore 5 instead of that, but it is taking from the .h file. Okay, So it is configuring the GPIO pin output level here. So this is LD2 pin GPIO port, that is port A, LD2 pin underscore pin, that is the pin 5 of port A, and GPIO pin reset means it is 0. Okay, so this is the output level. We are configuring this. So then if you'll see here, configure GPIO pin. So this is the B1 pin. This is used for your push button. I told you, right, one push button is there. Okay, then one more is configure GPIO pin, LD2 pin. So this is LD2 pin. See, we have one GPIO init structure. In that, pin, mode, pool, and speed all are defined in the structure, and that structure is passed to this function HAL GPIO underscore init. So, and here LD2 GPIO port, that is port A, we are passing the structure as an argument. So all these things will be configured based on this configuration. Okay, so here what we are doing, we are configuring port A pin 5, that is LD2 pin, as output pin with positive pull up. Output is PP, positive pull up, then this is no pull up, and this is output push pull mode PP. Okay, so and frequency is low frequency, so we are initializing this port with this. Okay, so if you see all the code blocks, it has two sections. One is the fixed section, and another is user code and while user code begin. Okay, so if you'll see, uh, if we want to write anything, we need to write between this user code begin from this comment section to this comment section. If we will write something outside of this, then the next time we will configure the IOC and save, that section will be deleted by the IDE itself. Okay, so if we are writing something, we have to write when it is a STMQ project, so we have to write between these two comment lines. Okay, so here we need to write, if we need to write something here, we need to write here, and similarly if we are writing something, we are declaring some variables, or we are initializing something, then we have to write here. Okay, so take a note of that, otherwise whatever we will be writing will be deleted. Okay, so if you'll see here, let us go back again. So it included the main.h, which is this one, auto generated. Then it is having some private function prototypes. So these are the prototypes of all private function whatever there. Then this is the main function, and in the main function all the initializations are done, and in the while loop we'll be writing our code for the blink LED. Okay, so how to do that? Okay, so for that we need to go to see our files are here, or whatever we are changing, like that main.c, main.h, those are here. These are some of the driver files and HL layer, which is already included, and this we don't have to do any changes here. And our aim is to toggle the GPIO, correct? So how to do that? So we have to go, so we to access any of the GPIO or any of the resource in the microcontroller, we can refer the ARM documentation for HL, but that is one way, and the other way is we can go through the drivers here. So include, then it will see here this is the SIMSys driver, that is okay. This is ST. So this is the SIMSys driver related to ST, and include, if we go here, it will include all the correlated things. And HL driver, yes, and this is STM32 GPIO.c. Okay, so either we can open this, or we can just for a quick reference we can go here and we can open this. So if we see here drivers, then STM32L4 series HL driver. So here in INC section, go to this HL underscore GPIO.h. Okay, because we are trying to access the GPIO, so we'll have to see the prototypes here. Okay, the function prototypes. So if you'll see what are the available functions. So yeah, so HL GPIO read pin we are not reading, so when we program the push button we can use this. So in our case, either we can use HL GPIO write pin, or we can use HL GPIO toggle pin. Okay, so what is the prototype here? HL underscore GPIO underscore toggle pin, and this is GPIO type def GPIO X. This is the pin port, sorry, and the port will be passing as an argument, and here is the pin will be passing. Okay, so if we'll call this function, it will toggle the pin. So let us copy this, okay, and go to our main function, and here in while loop, this is user code error handling debug error. This is error handler. This is okay. So this is the user code building for a while infinite loop. So I think we don't have to go through by using the super loop or the while loop. Okay, so I consider that you already know that. Okay, so here we can just go through your initialization, and you can, because if you don't remember that pin, then it is okay, but we should know what is the port and pin we are trying to access. Okay, so if you see, for blinking the LED, we need LD2 GPIO port, that is port A. So just copy, Control C, and that is file loop. To go here and just press Control key. Okay, and LD2 port pin, we need to take the pin. So this is LD2 pin. Okay, so now what this will do is it will toggle the pin LD2. Okay, that is the pin 5 of our port A, but it will toggle so fast that we won't be able to see it unless we have some delay. So to introduce some delay, again we can go to the HL library document. So what are the available macro available functions, or we can just HL. So as I remember it, I am typing. So 500. So HL delay under HL underscore delay 500 means 500 milliseconds. So if you want to see the macro here where it is, just click it, and you'll find that in STM32L4 underscore HL.c we have one function like HL underscore delay. Okay, so this will toggle the pin. If it is high, it will make it low, then wait for 500 millisecond, again it will come, again toggle from low to high, and this will continue forever. Okay, so let us see how it is behaving here. Okay, so we need one USB type A to USB type B mini cable for this, for the connection. Most of the time it comes with the development board, but in case it is not there, then we need to just get one USB type A to type B mini, connect it. So if you'll see, it is loaded with some similar kind of program which is blinking this LED. Okay, no worries. This is the power LED, I think. So the board is getting power from the USB cable, so we don't need any external power supply. And this is again indicating the power. This is indicating power to the development board. This is the ST-Link programmer here. Okay, so this is our LED which we are trying to blink. We have not yet loaded the program. This is blinking because of some program already loaded into the board. When we get the board, some program is already loaded. Okay, so no worries, we'll check whether our file is working or not. So if you'll see, it is opening some of the thing. Just close it, nothing to worry. And here we can just build the program. So for building, you just click build. So this will not load the program. Just see whether our code is building properly. Just click build it. So you will see build finish, 0 errors, 0 warnings, and okay. So this will give you the utilization of the memory and the flash memory and RAM space. Okay, I will not go through that now. Okay, so if you'll see, our program is building successfully. Our board is connected to the USB port, so it should automatically install the driver in the PC, else we may get some issue. So see if that is not installed properly in your device manager, if it is giving some issue. But in case, most of the time it should install successfully without any issue. Now if everything is done, we can just go ahead and run. Okay, so this is the thing, and this thing, so debugger, this is still in. Okay, so this is fine. Okay, I will be using anything AWD interface or JTAG interface. Okay, so we'll see. Yeah, it is waiting for debugger connection. If you'll see, this is blinking, it is waiting for the connection. Just press the reset button once. Okay, it has failed. Okay, I think it took some time to press the button. No worries, we can press it. Okay, download verified successfully, shutting down, exit. So yeah, it is downloaded. So as you can see, the frequency whatever we have set, 500 millisecond, with that it is blinking. If you want to still verify that whether our program is running or the previous program is running, let us change this to 100 millisecond here. So this is 100 millisecond, and okay, Control S, again directly we can press run. So it will build it, and it will try to load it. waiting for the connection, press the reset button. So debugger connected. Okay, download verified successfully. Yeah, so if you see now the LED is blinking at a faster rate, that is each 100 millisecond it is toggling the LED. Okay, so yeah, our program is running, and hope you could understand how to get started with this. Okay, so the program is running well, and we saw that whatever we are changing here, it is reflecting in the board, in the hardware. So that's all for today. Subscribe, like, and give your comment. In subsequent future videos, we'll explore other peripherals, and we'll dive deeper into all the resources whatever is there with this controller. Thanks. Have a good day. Bye. Take care.